Hey, Ethan. We're going to be looking at some graphs of circular functions now, so mainly sine and cos graphs. What I've got up here is something to hopefully show you how it works and how we actually get the shapes of a sine and cos graph. So here's our unit circle. Hang on. Here's our unit circle, which we've sort of been working on the last couple of lessons. But don't worry about that just yet. We'll see we've got a couple of graphs over to the right here. Now, I want you to not worry about the grey line here, that's a tan graph. I just want to worry about the green one, which is a sine graph, and the blue one, which is a cos graph. Now, they look sort of familiar in the way that they look like parabolas that have been kind of joined together, one's flipped upside down. But I want to show you why sine and cos graphs actually have this shape. Okay, so let's go back to our unit circle. Do you see how when I move my mouse around, it changes that sine length and it changes the cos length as well? So let's just focus on the green one for now, which is sine. So let's just say we're starting with a degree of 0. Do you see how it says sine 0? And we can see that there's no green line there either. But if I go around the circle, do you see how that line is getting bigger, 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 bigger until it reaches its peak up here? And then it's going down, so it's getting smaller, 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 smaller until it's 0 again. And then it goes into the negatives. So it's getting closer to -1, reaches -1, and then as we go around the circle again, it's getting closer to 0. So hopefully you're watching the unit circle then, but what I want to do this time when I go around is see that the green line over here, it's trying to graph the size of that sine component. All right, so I'm going to go around. Do you see how it's getting bigger on that right side? Reaches its max, then goes down, goes into negatives, and then comes back up. So that's why a sine graph actually has that shape. Okay, so it hasn't just been pulled out of thin air. It's been taken out of the unit circle. Okay, now let's do the same thing, but look at cos. Now cos is our blue line here, so it actually starts at 1. And you'll see that up here, see how that starts at 1 as well, the blue line. So as we go around, that cos component, the blue line, is actually getting smaller. So on the graph on the right, can you see how it's getting smaller until it gets to 0? And then it's going towards -1. Then it gets to -1, and then it's coming back to 0. So again, just like we did with our sine, it works the exact same way with cos. Now on the right side here, they've only shown one cycle. Something that's important to know is that it doesn't necessarily stop. These just go on forever and ever. Okay, so it's just going to keep doing the same kind of pattern or the same cycle, depending on how many rotations around the circle that you do. So if I did 1 rotation, that'd be that complete graph. But if I went again, it might draw another cycle after that will connect up. Okay, so that's the idea behind why the graph is that shape. So I'm going to start having a look at the problems that we are going to have to learn to solve to do with this sort of stuff. So I might try something different here, guys, and do a couple of questions on Google Docs. Next year and the year after, you're going to have to sketch these graphs of circular functions, but at the moment you don't necessarily have to. Sometimes you're going to be given graphs just like this, so see how this has already been sketched for you, but they might ask you some questions about it. So what we're trying to learn how to do right now is read how this graph works. Okay, so what it's actually saying before I go through any of these questions is, what's the cos length of any triangle on the unit circle, and what's the angle? Okay, so if I go to 90 degrees, I'll choose that because it's an easy one. We can see the cos length is going to be 0, it's on the x-axis. Or if we choose 0 degrees, we're going to see the cos length is going to be 1. Now what you should hopefully see if you look at your exact values table is they're the values that you're going to find in there. Okay, so let's have a look at these few questions and try to read it. We might not be exact here. It just says estimate anyway. So estimate the value of cos theta for the following. So if theta is 30 degrees. Okay, so if theta is 30 degrees, let's have a look along here. Each one of these notches is 10 degrees. and each one up here is 0.1. 30 degrees, so 10 degrees, 20 degrees, 30 degrees is just here. So it looks like our cos length for 30 degrees is around about 0.9. Okay, so we could say that cos 30 is around about 0.9. I'll do equals, but I should do approximate. I don't know where the other button is. 0.9. Cool. So let's do that same sort of thing again, but this time we're looking at 260 degrees. So 180, 270 is there. So 260 must be this one just here. So if I go down, it looks like for cos 260, that horizontal length of the triangle is going to be negative 0.2. See how I've gone down on and found on the line? So I can say that cos 260 equals negative 0.2. Okay, so that time we were starting off by looking at the degrees and then finding the length. This time it's going to be a little bit different with these two. So it says estimate the two values of theta, so the two angles, where cos theta equals negative 0.9. Okay, now negative 0.9, negative 1's there, so negative 0.9 would be along here. So that would be the length just there. So I can see that the line, when it has a length of negative 0.9, looks like it hits here and it hits here as well. So if I go up, it looks like that's about 150 degrees for that one. And the other one over there, looks like it's about 210. Okay, so we could say that to get that answer of negative 0.9, theta would be 150 degrees. I'll just make it quick here because I'm on Google Docs. Degrees. There we go. So that's answering that one. Do you see how we sort of went the other way around? Instead of starting on this axis, we started on that one instead. All right, so now we want the angle where we have a reading of 0.2. So 0.2 would be here, and we can see that we have 0.2 at this spot here and this spot as well. Okay, so it looks like that's at 80 degrees, and the other one over here looks like it's at 280 degrees. So there'd be our two answers for that one. So let me put that in. It was 80 and 280, wasn't it? So there we go. Now I want to go and look at the calculator for a second, because there's going to be some questions that look like this. They might give you something like sine theta, but I'm going to use x for now, equals, I think 0.3 is the first one, but I'm going to change it to 0.4. Now, from what I've shown you using the CAS before, we can do this really quickly using the calculator. So we want the solution for x, don't we? We want to know what x is. So we're going to solve for x. So I've done this a handful of times, so we've done this a handful of times together, so hopefully we'll remember this sort of thing. And I'll press enter and it should tell me the value for x. Alright, now this looks a bit yuck, doesn't it? What's this n1? Now the reason this has happened is it's giving us all the solutions, but remember when I was showing you the graphs before, I talked about them being cycles and they just keep on going. So like if we use the other one as an example, if we use this as an example, this would keep on going, okay? It's just that we haven't drawn any more of it, so it might go out like that. And I haven't told the calculator to stop here, even though this is a different graph. So I'm going to have to tell the calculator that I want it to actually stop and only give me certain values. So you might be told that you only want the angles between 0 and 360, so I'm going to tell it that. Now you need to click Control, you see that little vertical blue line, that's what you want. So Control equals, and then that there. So this is Like it means given that. So you'll be able to give it certain x values that you want it to use. Okay, so it's only going to look inside those x values and no other ones. So we wanted the x values between 0 and 360. Now this might seem a little bit complicated at the moment. If you don't get it straight away, that's okay. Come and ask me. It's something that you're going to use flat out later. Okay. All right, so this time I've told it I want it between 0 and 360 degrees. See, I've got degrees in the corner there. Press enter. There we go. It's giving me the answers that I want. So your sine length is going to be 0.4 when your angle is 23.58 degrees and 156.4 degrees.